All right, when you arrive, things are going to be looking something like this. Sodium chloride, sodium hydrogen carbonate, solidified esters laid out ready for you to use. I have solidified esters on my element number 13 in preparation of forming the final product. So that setup will be ready for you. In addition, there'll be a beaker, and that beaker is going to be looking something like what you see right there. In that beaker, I've combined dihydrogen monoxide, sucrose, and a solution that contains a molecule called glucose. So that's all ready to go. When you arrive, then, we're going to get our burners going. And I have a little trouble with my burner this morning. There we go. Want a little bit of a gap between the flame and where our beaker actually lies. There are some objects that are going to be unique to this particular activity. I have some silicone-based protectors that I'm going to be using to manipulate the handle here. If I don't have a handle, then I have a special set of tongs that will wrap around our beaker. Let me show you what that looks like. And so these tongs are available for those that end up with beakers that don't have a handle off to the side. So, first part of this activity is to get our solution to bring to a boil. That takes about 10 minutes. And once we've brought it to a boil, we're then going to add our solidified esters. We're going to stir vigorously. We then add our protein pellets from Arachis hypogaia. That's going to bring the temperature down. We have to bring the temperature back up again. We will then be finally adding our sodium hydrogen carbonate along with our sodium chloride, and this is methoxybenzaldehyde in just the amount that you're going to need. So again, all of these things be laid out in advance for you. We're simply waiting for this to come to a boil. Now you see that it is boiling and it is transparent. It's from this point, well, what's happening is that we're driving off the water. Dihydrogen monoxide is fleeing from our mixture as it goes. What I now do is add my solidified esters. I'm scraping them directly onto my linen-based paddle, and I'm using that to then transfer them into this very hot mixture. Once again, stirring. Notice how it foams up upon the addition of our solidified esters. The reason for that, our solidified esters actually contain a lot of water, and that water boils away quickly. I don't want this to boil over, so you can see that I'm stirring a little bit more rapidly than I was before, but very careful not to splash. So again, a little more rapid in my stirring, but still being extremely careful. Now I'm just going to pull this back a bit and see where we are. Okay, so that foam again continues to rise up in my beaker, stirring carefully. That reduces that foam a bit. It helps to break up those bubbles. At this point, we're going to be looking for a color change. That color change accompanies a change in the thickness of this material. That color change goes hand in hand with the conversion to the hard crack that we're looking for. We're going to go from a very light, I would describe this as a kind of straw color, to a slightly brown tan. Very slight, it's a very subtle color change, but one that with an experienced eye you can pretty much identify very quickly. And the feeling that I have as I stir indicates to me that this has gotten very thick now. I'm going to let this boil for another 2 minutes, and then I'm going to add my protein pellets. The protein pellets carry away a lot of heat, so we're going to have to reheat we're going to keep the flame going after we've added our pellets, just to keep that temperature back up again. Okay. So, holding on to this beaker, I'm pouring directly over the flame. I've added my protein pellets. Now I'm stirring. My hand that's stirring right now feels quite a bit of heat, but it's not terribly hot. So again, if I were uncomfortable, I would simply call over my lab partner and say, hey, I need some help. Notice how the boiling ceased when we added the pellets, but that boiling is restored very quickly. That's good. All of this is happening exactly as it should. Now, I would like to get a very small amount of, well, burning. Very tiny. I'm looking at the bottom. I'm trying to make sure that I haven't burned anything yet. But yes, I want to get this very, very hot. Whoa. This, in and of itself, can get hot. If it has gotten hot, what you want to do is to run water over the surfaces here. Don't get any water inside this thing. Putting it down for a minute will help it cool off as well. But it's very effective at protecting us from the high temperature of that handle. Okay, so again, I'm stirring. Nothing's burned yet. But yes, I want a faint, small amount to turn very dark. That's not happening yet. Okay, so we're about 25 minutes into this. And that's because I started with a larger quantity than you will be starting with. Still able to stir, and yet it's very thick. I am now going to add my sodium chloride, not the sodium hydrogen carbonate. What's the difference? The sodium hydrogen carbonate is a very fine powder. The sodium chloride are much larger crystals looking like grains of sand. So you'll be able to distinguish those, but we will label them carefully for you. So here comes the sodium chloride. Very small amount. Stirring again. Aha, now I'm seeing some darkening. Of my reaction mixture. Very thick now. Okay. Notice I'm gently stirring. And because this is so thick now, I do have to hold on to it, the handle. The only reason why I'm sitting is so that you can see me while I'm working on this. You're going to be standing. Again, the hand that's doing the stirring is feeling quite a bit of heat, rather uncomfortable. The hand that's holding on to the handle, that's starting to experience a little bit of heat radiated through the protecting glove that I'm wearing. I will be helping you judge this particular color. We are almost at the color that I like. I'm actually going to turn the heat off before I achieve that perfect color that I like, because the glass is so hot that it will continue to radiate heat into the material that we're working on. So we really don't need a flame in the very final steps of our synthesis. You need to be stirring this at this point. I'm seeing some dark brown coming up as I stir. That means the bottom is starting to scorch a bit. Perfect. I've turned off the heat. Now my baking soda, my sodium hydrogen carbonate, has gone in. This is very hot. I'm stirring. What am I looking for? As the baking soda goes in, my product should be foaming up. It should be climbing up the sides of the container, indicating that I'm at the correct heat for this process to have occurred. Do you see how it's rising up? Okay, rising up very quickly. Now, this is a little bit dangerous. Notice that the flame is off and I'm adding my benzaldehyde compound straight into this mixture. The reason why I say this gets a bit dangerous, that stuff boils away and the steam that it forms can be very painful. So notice that I'm keeping my hands away. But now I'm back to stirring, and now I take my material, and it's not so much that I'm pouring as I'm scraping with my linen-based paddle. I do not want to touch the mound that's forming on my element number 13. And that, ladies, is how we make our partially thermally decomposed sucrose carbon dioxide foamed with protein inclusions product. We're now going to add some hot water to this thing. We're going to boil that hot water, and that's our cleanup. Goes back over to here. This is too hot to touch. In about 10 minutes, we will test the brittle characteristic of this material. I want to remind you that I coated my element number 13 with solidified esters. I had sodium chloride and sodium hydrogen carbonate on 2 different pieces of parchment paper, and then I've got the solidified esters that I put in there. Among the tests that we perform on our final product is a test for brittleness. It's an Olympic year, to be followed by an Olympic year. So we have to be very, very careful in regulating how we're going to do this test. So at the top of my finger, with my elbow at the top of the table, I'm going to drop it exactly this height. Okay? So that's the height. When it hits, I'm looking to see, oh yeah, how it has broken up, how brittle that is. Aha, mine is still so hot that it's actually bending rather than shattering, but you can see that at the edges it is shattering quite well. What we're looking for there are a series of very tiny, very difficult for you to see, but very tiny pockets have formed inside there. That's the foam that's coming from the carbon dioxide released when sodium hydrogen carbonate is heated. So, we're going to be learning quite a bit about the chemistry of what went on here in our next term. That is our final product for our partially thermally degraded saccharides foamed with carbon dioxide, including protein pellet inclusions.